Good day everyone, my name is 𝗬𝗵𝗲. I'm working at the research organization PROFACTOR in Austria. At PROFACTOR we are coordinating a European research project called 𝗕𝗵𝗲. The aim of this project is to develop remanufacturing processes for sheet metal and for composite parts. These processes should then be supported by a digital product passport that collects information along the life cycle of the part and then provides this information when it comes to giving these parts a second life. At PROFACTOR, we are developing automation technology that helps with this process on 3 occasions during the life cycle of the part. In the first place, we are looking at quality control, where we are developing sensors that acquire defect information about the part. At the second stage, when parts are in use, we are providing repair assistance that help with the repair of, for example, impact damage. And at the final stage, we are supporting dismantling processes to optimize the reuse of the material. I start at the beginning of this process with quality control. For this purpose, we are developing sensors, mainly for the inspection of composite parts, that are acquiring information about defects on the part. They can determine the location where they end up in the final 3D part. This allows us to establish whether rework is required. For example, if the defect is placed in a window that's cut out afterwards, then obviously no rework is needed. In any case, all of these data will end up in the 3D model and will be available for later use along the life cycle of the part. At the second stage, when the part is already in service, problems such as impact damage may occur, for example, on composite parts. These parts then need to be repaired. Repair is often a manual process, which makes it difficult to track where exactly the repair has happened. For this purpose, we are developing tools that allow to record the 3D position of where exactly the repair has been done and to transfer this information into a 3D CAD model so that it again is available for later use along the life cycle of the part. And finally, at the end of the life of a particular part, we are supporting the dismantling process. Larger structures, such as aircraft, can be cut into different pieces, and we are looking into robotic cutting processes and provide what we call a cutting planner, which optimizes the cutting process to maximize the amount of material that can be regained. This cutting planner uses information about defects in the parts, any kind of repair that has been done, and any other information such as the type of material that is being used in order to generate second life parts that maximize the reuse of material and resources along the whole life cycle and as the part enters into its second life. The innovation that these products provide is that they acquire information along the whole life cycle of the part and make this information selectively available for different stakeholders along the life cycle of the part and as the part enters into its second life. The current stage of development is that all of these tools are available at individual level, and in the next months we'll be working on making them available in an integrated way so that they can support the whole process in production lines, during in-service and at the dismantling stage. If you are interested in receiving more information, then please check the webpage below or contact me directly with the email that's shown below. Thank you for listening.